Imagine holding your modern smartphone in one hand, and then in the other hand, just like a rusty, barnacle-covered lump of bronze.
Right, which sounds like garbage.
Yeah, exactly, garbage. But what if I told you that the fundamental logic running both of those devices is, exactly the same?
It's a pretty wild concept.
It really is.
Yeah.
So welcome to today's deep dive. We are going to conduct a sort of forensic data recovery of the human story today, specifically for you listening. We've got some incredible source material.
Yes, the ancient archive blueprints.
Right, the ancient archive blueprints, and they're decoding the pillars of history logs. And our core mission here is to just shatter this massive myth. We've basically been conditioned to believe that ancient automatically means, well, primitive.
Yeah, the sources actually call this stone bias. It's a really flawed assumption that if an ancient invention wasn't carved out of, heavy rock, it simply didn't exist.
Right, because rocks survive. But it's a massive blind spot, isn't it?
Oh, absolutely. I mean, we are taught to look at the historical record as this neat, linear, upward progression. Exactly. We build a wheel and eventually, boom, we get to the microchip. But when you actually look at the archaeological data, it tells a completely different, much more volatile story.
Yeah, I want to start with this ultimate biological paradox the sources outline. They call it the 200,000-year loading screen of humanity.
That's a great term for it.
Right, because for 200,000 years, the biological processor, meaning the human brain, was completely identical to yours and mine today.
Same cognitive capacity, same vocal hardware for language.
Yeah. Yet mainstream history basically asks us to believe we just sat around doing absolutely nothing. Like occasionally chipping at a piece of flint until we suddenly, woke up and started innovating about 5,000 years ago.
Which logically doesn't hold up.
No. It's like having a top-of-the-line gaming PC, but for 200,000 years you only turn it on to play Pong. It just doesn't make logical sense.
Well, the math on that timeline is highly suspect. That massive void in the historical record is what the blueprints term an archive of deletion.
An archive of deletion. I like that.
Yeah, because it's not a lack of ancient intelligence. It's really just a lack of material preservation. I mean, much of early human innovation was likely soft tech.
Soft tech. So, what does it mean in this context?
We are talking about sophisticated botanical chemistry, advanced textiles, complex wood, and acoustic engineering.
Stuff that rots.
Exactly. These are materials that simply rot away. And furthermore, we have to factor in the submerged library.
Right, the sea levels.
Yeah, because of post-glacial sea level rise, the original coastlines where early humanity actually thrived are now sitting under like 400 feet of ocean water.
Wow. So the evidence of human mastery isn't missing because it never existed. It's missing because it sank or biodegraded.
Precisely.
I mean, we might not be the first advanced version of humanity. We might just be the latest iteration that got lucky enough to have a period of climatic stability so our stuff doesn't, get wiped out.
Right. The baseline of what we consider human capability needs a serious adjustment. Because the hardware that actually did survive the millennia forces us to completely rethink the ancient mind.
Yeah, let's get into the hardware then, because the sources outline Pillar 1, the technological paradox.
Yes. Artifacts that simply shouldn't exist according to our traditional timeline.
Okay, let's unpack this. Let's start with the Antikythera mechanism. Divers find this rusty lump of rock in a shipwreck off the coast of Greece in 1901.
And they thought it was just debris at first.
Right, just junk. But when modern science finally X-rayed it decades later, they found over 30 interlocking bronze gears. It's literally an analog computer from around 150 BC.
It is.
But, how does a lump of bronze compute anything?
What's fascinating here is the sheer mathematical precision and physical geometry. It wasn't just a clock keeping time, it was a predictive engine.
A predictive engine?
Yeah.
So it was forecasting things?
Yes. The device used an incredibly complex system of overlapping gears to track the solar and lunar cycles, predict eclipses down to the hour, and even map the movements of 5 planets.
That is insane.
And to do that, they had to employ something called differential gearing.
Okay, wait. I drive a car, and I know I have a differential in my axle, but how does that apply to a bronze computer from 150 BC?
Well, think about your car turning a corner. The outside wheel has to travel a further distance than the inside wheel, right?
So it has to spin faster.
Exactly. Differential gearing is a mechanical principle that allows 2 shafts to rotate at different speeds while still being connected to the same mechanism.
Oh, wow.
The Greeks were using this exact principle to calculate the differing rotational speeds of the moon and the sun simultaneously. The mathematical precision and mechanical logic required to build that device just vanished from Europe and didn't reappear for another 1,400 years.
1,400 years. So it proves the ancient Greeks were literally coding in bronze.
They really were.
Well, if they were building analog computers, my immediate next question is about power. Like, did they have electricity? The sources bring up the Baghdad battery, which dates back to around 250 BC.
Yeah, that's always a controversial one.
Right, skeptics constantly push back on this. They claim these were just jars for holding sacred scrolls. But the sources detail the specific components. You have a clay jar, a copper cylinder, and an iron rod, all sealed with an asphalt plug.
Very specific materials for a scroll jar.
Exactly. So if we take those exact components and add an acidic electrolyte like, say, vinegar or grape juice, does it actually do anything? Or is it really just a jar?
Well, when researchers build replicas using those exact ancient components and add vinegar, it functions perfectly as a galvanic cell.
Wait, really?
Yeah, the acid reacts with the two different metals, the copper and the iron, and it creates an electron flow. It produces a real electrical current.
Okay, hold on. The blueprints say it only produces roughly 0.8 to 2 volts. I mean, my TV remote needs more power than that. What is an ancient civilization doing with a 2-volt trickle of electricity? It seems, I don't know, completely useless.
Well, if you are trying to power a motorized machine, sure. But if you are using it for chemistry, 2 volts is exactly what you need.
Chemistry.
Yeah, the most prominent theory is electroplating. You can use that small electrical current to dissolve gold into a solution and basically fuse a microscopic layer of it onto silver jewelry.
Oh, wow.
It suggests an incredibly sophisticated understanding of invisible forces predating our own age of power by millennia.
Okay, but if they were electroplating, that implies a grasp of microscopic chemistry. Did
Right.
they go smaller than that?
Right.
Because the sources pivot to molecular engineering, and they use the word nanotechnology.
Right.
And I exclusively associate that word with, modern guys in white lab coats.
Most people do. But the archaeological record shows us that ancient civilizations were manipulating materials at the atomic level.
Yeah, I was reading about the Lycurgus cup in the logs. It's this 4th century Roman glass artifact. From the outside, the glass looks opaque green. But if you shine a light from the inside, the whole thing glows a brilliant, translucent ruby red.
It's a beautiful piece.
For decades, nobody knew how it worked. How are the Romans changing the color of light with glass?
They were applying the same principles we use today in modern fiber optics.
You're kidding.
No, they impregnated the glass with gold and silver particles, but they ground those particles down to exactly 50 nanometers.
50 nanometers.
For context, a single strand of your hair is about 80,000 nanometers wide.
That is just incomprehensible.
By suspending these microscopic particles in the glass, they were actively manipulating how light scatters at a molecular level. We didn't even understand the physics of how that worked until 1990.
1990. And it wasn't
No.
just decorative glass, right? Like, I was heard Damascus steel was just ancient blacksmithing lore. The famous swords from the 10th century with those beautiful wavy patterns that could slice through falling silk.
Yeah, the classic myths.
Right, I assume that was mostly myth. Is there actual science behind it?
There is, and it completely shocked metallurgists. When scientists finally put ancient Wootz steel under an electron microscope, they found carbon nanotubes and cementite nanowires running through the metal.
Wait, carbon nanotubes? Like the stuff we use to build aerospace components today?
The very same. Through a highly complex temperature-cycled forging process using specific impurities like vanadium, they were forcing the carbon to bond into microscopic structural tubes.
So they essentially created an ancient carbon fiber composite.
Exactly. It was molecular engineering achieved through trial, error, and just an unbelievable intuition for metallurgy.
Okay, manipulating light and forging nanowires is mind-blowing. But it's one thing to make a cup glow or forge a sword. It's another to build a city. Did any of this microscopic science translate into actual durable infrastructure?
Oh, absolutely.
Because when I look at modern construction, like a concrete highway overpass, it's cracking and crumbling in 50 years. Yet there are Roman seawalls and piers that have been battered by salt water for 2,000 years, and they are rock solid.
Yeah.
Here's where it gets really interesting. The sources say they are actually getting stronger. Why does a modern bridge fail, but a Roman pier lasts forever?
Well, researchers only fully decoded this Roman secret in 2023. Modern concrete is designed to be a static material. Once it sets, any stress causes irreversible cracks.
Right.
We used to look at Roman concrete, see these little white chunks in it, and assume they were just doing a sloppy job mixing their mortar. But those chunks were lime clasts.
Lime class.
Yeah. The Romans used a specific hot mixing technique with volcanic ash that left these reactive pockets of lime throughout the structure.
So they intentionally left reactive chemicals inside the walls.
They built a self-healing chemical trigger. When a microscopic crack forms in a Roman seawall and saltwater seeps in, it hits those lime clasts. This triggers a chemical reaction that creates a compound called calcium aluminosilicate hydrate.
Okay, that's a mouthful.
It is, but basically it instantly crystallizes, actively repairing and sealing the crack before it can spread. It is a dynamic, self-healing material that uses the very ocean trying to destroy it to make itself stronger.
If this formula is so vastly superior and lasts millennia, why hasn't the modern construction industry gone back to using it?
Think about the economic incentives. We have a global construction industry built on 50-year replacement cycles.
Whoa. Right.
There is very little financial motivation to pour concrete that lasts for 2,000 years. Planned obsolescence is highly profitable.
Man, that is frustrating, but it makes total sense. So having established their mastery over the microscopic nanotech, carbon structures, self-healing chemistry, I want to scale this up. The sources outline Pillar 2 engineering giants, and the sheer physical scale of some of these projects is, frankly, terrifying.
We are talking about logistics and structural manipulation that absolutely baffle modern heavy lift architects.
The Kailasa Temple in India is the perfect example. Think about the house or apartment you're sitting in right now. If the builders made a mistake, they could just grab another piece of wood or brick.
Right.
Well, the blueprints detail a 100-foot-tall cathedral. But the ancient engineers didn't build it. They found it.
Right, by removing the mountain around it.
Yeah. They removed 200,000 tons of solid basalt from a mountain cliff face, and they carved it vertically from the top down.
It's called negative architecture.
It's unbelievable. If a carver makes a single mistake with a chisel over the 18 years it took to create this temple, they can't just put the rock back. The entire structure is ruined.
The spatial awareness required to envision a multi-story, intricate temple inside solid rock and then carve down to it without a single structural failure, I don't think we have the capacity to do that today.
I really don't think we do.
If we connect this to the bigger picture, it requires a command of geometry and structural endurance that we rarely utilize. And we see similar mastery on the other side of the world in South America with Inca vibratory masonry.
Oh, yeah?
If you look at sites like Sacsayhuaman, you see these massive multi-ton stones cut with internal right angles.
They look like giant interlocking jigsaw puzzles. But they don't use any mortar. I just don't understand that. Why go through the agonizing trouble of carving rocks to fit so perfectly? A credit card can't slide between them. Why not just use mortar like every modern bricklayer does?
You have to look at the environment. The Andes are highly seismically active. Mortar is rigid. In an earthquake, mortar cracks, crumbles, and the wall collapses.
Oh, I see.
By fitting the stones together like complex interlocking geometric puzzles, they allowed the walls to be completely earthquake-proof. During a tremor, the stones literally dance.
They did.
Yeah, they shift, dissipate the kinetic energy of the earthquake, and then resettle perfectly back into place. Massive scale in the ancient world wasn't just about showing off by moving heavy rocks. It was a highly sophisticated command of gravity, kinetic resonance, and environmental adaptation.
Moving 800-ton stones, organizing an 18-year top-down mountain carving, managing vast empires. You just can't do that without incredible societal organization.
Which brings me to a huge logistical question. How did these ancient empires function without modern digital software? Like, how did they track anything?
Well, they ran their empires on incredibly robust analog software.
The sources dive into Pillar 3, modern versus ancient, comparing our digital tools to their analog ancestors. Take your daily commute. We use digital topological schematics like Google Maps or a subway map. They distort perfect geography to prioritize travel data. You don't need to know the exact GPS coordinates. You just need to know how many stops until you get off.
The Romans engineered the exact same concept with the tabula pugeriana.
The what now? The tabula pugeriana. It was a 22-foot-long parchment map of the entire Roman world. It wasn't geographically accurate. It was a linear strip.
Oh.
It prioritized the data a traveler actually needed, the distances between staging posts, the locations of hot springs, icons for major cities. It was a vast, wide-area navigation database, hard-coded onto parchment.
And it was designed specifically to interface with the physical hardware of their world, which was the Roman road system. And what traveled on those roads? The cursus publicus, the Roman postal and courier network.
Right.
We think of modern logistics as peak efficiency, but the Romans had relay stations spaced exactly 1 day apart. They could swap horses and riders seamlessly, allowing for packet transfers of data and physical goods across 50 miles a day. It was literally an analog internet.
And to run an economy of that scale, you need a highly secure operating system for trust. Before we had digital ledgers and crypto hardware wallets, the global trust protocol was established by the Lydians in the 7th century BC.
With Lydian gold coins. But how does a piece of metal act like a digital ledger?
It acts as a state-verified hash. These were electrum coins stamped with a royal lion's head. Before this, if you wanted to trade, you had to weigh raw bullion at every single transaction, which creates immense friction.
Right, slowing everything down.
Exactly. The stamp guaranteed the exact weight and purity of the metal. Suddenly, trade could move at high speed because the friction was eliminated. It standardized the unit of value across borders.
Okay, so they had the topological maps, the high-speed logistics, the secure currency. But how did they crunch the massive amounts of data an empire generates? This brings us to the abacus, a wooden frame with sliding beads. I mean, I look at it and see a child's toy. How is a frame of beads considered a computer?
Because it uses positional notation. The columns represent ones, tens, hundreds. The beads are physical placeholders for mathematical states. It is the exact same logic used in modern coding arrays. You slide a bead up, you change the state.
And it's incredibly fast. The logs detail a famous speed trial from 1946. They compared a highly skilled Japanese abacus operator against a modern electric calculator. The wooden abacus won. It processed complex math faster than an electric machine.
Which perfectly sets up the most profound concept in the source material, which they title 1, the null logic.
Yes, the focus on the null logic from the decoding logs. What exactly is that, and how does it connect to us today?
It is the absolute foundation of everything we consider modern. If you want to trace the lineage of the silicon microchip in your smartphone, you have to go all the way back to ancient Indian philosophers.
Okay.
They conceived of a spiritual concept called Shunya. It was the concept of the void, or profound nothingness.
Okay, but how does a spiritual idea about nothingness become a computer chip?
Because ancient mathematicians ran into a practical problem. Try doing long division with Roman numerals.
Oh, that sounds like a nightmare.
It is a nightmare. They needed a practical way to signify an empty column on their counting boards. So they took this spiritual concept of the void and adapted it into a physical placeholder, a simple dot. They invented zero.
Wow. They turned nothing into a usable mathematical tool.
Before the invention of zero, mathematics was strictly limited to physical, tangible quantities. You count 3 apples, 5 sheep. But by giving nothing a mathematical value, humanity unlocked entirely new realms of abstract thought, algebra and calculus.
That's huge.
The entire architecture of complex math was born from this ancient concept of the Indian void.
Okay, that jump from counting sheep to abstract calculus makes sense. But how do we get from zero to this silicon in my phone?
Fast forward centuries later to a mathematician named George Boole. He realized that if you strip logic down to just 2 states, 1 and 0, true and false, you can mathematically map any logical argument.
Oh, Boolean logic.
Exactly, Boolean logic. Eventually, modern engineers realized that Boolean logic perfectly maps onto electrical circuits. 1 represents power on and 0 represents power off.
Wow.
That simple binary architecture born from the ancient Indian concept of Shunya is the foundational operating system of every single modern microchip on Earth.
You know, it really makes you stop and think. When you're sitting in your car tomorrow on your daily commute, checking your digital map, waiting for an overnight delivery, paying with a digital wallet, and holding a smartphone running binary code, you are just running a highly polished silicon upgrade of a 2,000-year-old analog blueprint.
Yeah.
The fundamental logic hasn't changed at all, just the materials.
We are running the exact same software on different hardware.
Which leads me to the ultimate question of this deep dive. If humanity had analog computers in 100 BC with the Antikythera era mechanism, self-healing maritime concrete, molecular nanotechnology, and glass, and we understood the foundational math of zero, why wasn't there an industrial revolution in the year 70 AD?
That's the big question.
Right. The blueprints mentioned that Hero of Alexandria built a working steam engine in the 1st century. So where did all this magic go?
This raises an important question about the nature of human progress. The data shows us that progress is not a straight line. It is subject to something the sources call the tech reset.
The tech reset.
Events like the late Bronze Age collapse or the fall of the Roman Empire acted as massive systemic data deletes.
Because when an empire falls, it's not just the borders changing on a map.
No, it's the highly specialized logistical networks collapsing. The trade routes that bring the specific tin needed to make bronze dry up. The academies that teach differential gearing or molecular chemistry burn down, or are abandoned because people are starving.
Yeah, survival takes priority.
Progress is a cycle of brilliant, breathtaking peaks, followed by devastating losses. Technology is incredibly fragile.
Without active, continuous preservation, complex tech can vanish from the human record in a single generation. The math behind those Antikythera gears didn't just slowly evolve into better computers. It was violently erased from Europe and basically crawled its way back over 14 centuries.
It's a sobering realization about how quickly the lights can go out.
Which leaves us with a truly provocative thought for you to mull over. If human progress is a cycle of peaks and resets, and technology can vanish that quickly, what happens to our modern society? Think about it. Almost all of our collective knowledge right now is stored digitally.
Yeah, that's true.
It's on fragile silicon, it's sitting in massive server farms, it's floating in the cloud. If a massive collapse happens tomorrow, like a grid failure or a solar flare, we won't even leave behind carved stone temples or bronze gears for the next civilization to find.
Nothing physical.
We're the most advanced society in history, but our footprint is remarkably easy to erase. Will the next civilization, digging in the dirt 2,000 years from now, look at the decaying plastic and rusted metal of the 21st century and conclude that we were the primitive ones?
They might just look at our ruins and assume we were stuck in our very own loading screen.
Just waiting for the right software to boot up. Next time you look at a piece of modern tech, just remember, you might be holding the latest version of a very, very old idea. We'll catch you on the next deep dive.